lecture of partial fractions. So we will continue on the PowerPoint on which we started for this section. So, looking at repeated linear factors, they're of the form with the expression essentially over a factor that is raised to a power of n. So it says expression over f1 raised to the nth power equals a over f1 plus b over f1 squared plus c over f1 to the third plus dot 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 on up to the constant over f1 to the n, where a, b, c, so on and so forth to the constant are constants, right? So our approach here is once the decomposition form is determined, we need to multiply both sides of the equation by the common denominator on the left-hand side. We need to pick the values to eliminate some factors to determine unknown constants. Ideally, those will be those that make the factor equal to 0. If we do have a factor that is raised to a power of n that is greater than 0, we will have a significant amount more work. Let's go on to the next slide. Okay. Now, let's look at this example. 5x plus 8 over x plus 1 squared. All right. So the form that we're going to change this one into, if we start with 5x plus 8 over x plus 1 squared, the form we're going to change this one into is a over x plus 1 plus b over x plus 1 squared. Okay. Now, what we need to do, now that we've found out the decomposition form, is we need to eliminate the denominators by multiplying both sides of the equation by the common denominator on the left-hand side. Okay, the common denominator over here on the left-hand side is x plus 1 all squared. Okay, so we're going to multiply both sides by that. So basically multiplying everything times that x plus 1 squared. So this term, and that term as well. Now when we go to do that, on the left hand side it just cancels out. X plus 1 squared cancels out with x plus 1 squared. On the right hand side, I'm just going to apply it here, and then we'll cancel the terms in the next step. Oops, sorry, plus not equals. Okay. If you wanted to, you could write it on this side as well, instead of trying to skip a step like I was trying to do. And then you'll see that this cancels with this. One of these cancels. So that cancels that. And this entire term here cancels. So that it looks like 5x plus 8 equals a times x plus 1 plus b. Okay? Now, we need to figure out a and b. The easiest way to make this happen to start with, b doesn't even have an x associated with it. A has an x plus 1 associated with it. I need to turn that x plus 1 into a 0 so that I can cancel out that a term and solve for my b. So in order to do that, I need to let x equal negative 1. If I let x equal to negative 1, then what I can do, it says pick values to eliminate some factors to determine unknown constants. Ideal vectors will be those that make the factor equal to 0. We just did that. Okay, I'm going to rewrite the equation here. 5x plus 8 equals a times x plus 1 plus b. I'm going to plug in x equals negative 1. Here I get 5 times negative 1 plus 8 equals a times negative 1 plus 1 plus b. Here I'm looking at negative 5 plus 8 equals, well, a goes to 0, so it really just equals b. 5 minus 8 is 3, so my b must need to be 3. Now, here's where this comes in. Okay, I need to figure out what my a is. Fair enough. Okay, in order to figure out what my a is, I already know my b, so I'm going to go ahead and plug my b in. So I'm plugging 3 in for b. Now my x can be anything, right? I don't really have a restriction on my x here. I need my x to go away. In the first part, we just determined that it would be easy to use -1, right? I just need my x to go away, but I need to keep my a in this portion. So here I'm going to let x just equal 0. Okay, if I let x equal 0, then I get 5 times 0 plus 8 equals a times 0 plus 1 plus 3. Okay, 5 goes away, I'm left with 8 equals, now a times 0 plus 1, 0 plus 1 is 1, 1 times a is a. Looks like 8 equals a plus 3, which means that if I subtracted 3 over, that a would just equal 5. I have my a's and my b's. Now I can set up my partial fraction, right? So my partial fraction should look like 5 over x plus 1 plus 3 over x plus 1 squared, right? Because that was the initial breakdown that we had. It was a over x plus 1 plus b over x plus 1 squared. My a is 5, my b is 3. This is my partial fraction decomposition. And my answer. All right, let's try example 6. We're going to decompose this one into partial fractions. Here we have an x minus 4 squared in the denominator and 11x minus 3 in the numerator. So it should decompose into something that looks like a over x minus 4 plus b over x minus 4 squared. Okay. Now if we multiply the whole thing by the common denominator, we're going to multiply the whole thing by x minus 4 squared, which is going to give us 11x minus 3 times x minus 4 squared. I'm going to work the whole thing out over x minus 4 squared equals a times x minus 4 squared over x minus 4 plus b times x minus 4 squared over x minus 4 squared. If we simplify that, it simplifies down into 11x minus 3 because this cancels. And it simplifies down here to a times x minus 4 because this x minus 4 cancels one of these. So it cancels that out down to a 1. And then the x minus 4 squared here cancels completely out, and I'm just left with a b. Now, I need to choose an x so that a goes away. X minus 4 essentially needs to wind up being a 0, which means I need to choose an x equal to 4. Sure. So let's plug x equal to 4 in. So it's going to be 11 times 4 minus 3 equals a times 4 minus 4 plus b. Okay. 11 times 4 is 44 minus 3 equals, let's see, 4 minus 4 is 0 times a is 0. So it really just leaves us with a b here. 44 minus 3 is 41. So b just equals 41. I found my b. Now I can just plug my b value in. So I've got 11x minus 3 equals a times x minus 4. And then here, b equals 4, so it's just going to be plus 4. And I can choose any x value that I want to here. I'm going to choose x equals 0. If I choose x equals 0, I'm looking at 11 times 0 minus 3 equals a times 0 minus 4 plus 4. That's going to give me negative 3 equals negative 4a plus 4, which gives me negative 4a equals negative 7, which means that a equals 7/4. Double checking my math here to make sure that I did everything correctly. I think I did. And who could tell me where I messed up? I messed up. B is not 4, B is 41. I had a mistranscription right here. This is supposed to be 41. Oh man, that's great. So I need to subtract 41 over. Let's bring my eraser out. Hopefully you were screaming at the screen, Mr. Shipes, you did it wrong. All right, let's get rid of this. Sometimes I intentionally mess up to see if you're paying attention. It'd be too easy for me to do everything correctly, right? I want to make sure you're paying attention during lecture, and hopefully you're working it out as we go. So if I were to subtract 41 over, I'd wind up with negative 44 equals negative 4a. Easy enough, so that a equals 11. Now we're looking better. So let's go ahead and write down the actual partial fraction decomposition here. It's going to look like 11 over x minus 4 plus 41 over x minus 4 squared. Gotta be careful with your handwriting in your transcription there. Hopefully you caught it and were able to jump on it before I caught it for you. Let's go on to the next one. Number 7. We want to decompose this one into partial fractions. Now here we have an x plus 1 squared and an x minus 2. So we need to kind of combine what we learned in the first lecture on partial fraction decomposition and what we just learned when we have a factor squared. So this one should really look like 54 over x plus 1. Nope, sorry. Jumping ahead of myself here. A over x plus 1 plus b over x plus 1 squared plus c over x minus 2. We've got to consider all the factors. Then we still do the same thing. We need to multiply by that denominator on that left-hand side. So we multiply everything by x plus 1 squared times x minus 2. So let's get with that. It'll be a little bit of work here. I'm going to write everything out so that we don't miss any steps. So I've got 54 times x plus 1 squared times x minus 2 all over x plus 1 squared times x minus 2. You should notice that cancellation that's going to occur there. Here we have a times x plus 1 squared times x minus 2 all over x plus 1. Here we have b times x plus 1 squared times x minus 2 all over x plus 1 squared. Here we have c times x plus 1 squared times x minus 2 all over x minus 2. Now we get to do the lovely job of cancellation here. This cancels with this. Here the x plus 1 cancels with one of the x plus 1's there. The x plus 1 squared cancels the x plus 1 squared, and the x minus 2 cancels the x minus 2. Alright, so let's write the simplification down. Here I have 54 equals a times x plus 1 times x minus 2 plus b times x minus 2 plus c times x plus 1 squared. Alright, now we want some stuff to cancel out. We have plenty of x's to work with here. What I'm seeing right off the bat is that I probably should let x equal negative 1, and I should probably let x equal 2. Okay, those will be 2 iterations, and then we'll see what happens after those 2 iterations. Okay, so I'm going to start with the first one, x equals negative 1. If I let x equal negative 1, I'm looking at 54 equals a times negative 1 plus 1. So my a value is going to cancel out right there. And then b times negative 1 minus 2. Hopefully you're working along with me. Plus c times negative 1 plus 1 all squared. Which means that 54, like I said, the a term cancels out because negative 1 plus 1 equals 0. We might wind up multiplying that whole first term by 0, so it zeroes out. The only term that really sticks around, because the c term goes away as well. Negative 1 plus 1 is 0, 0 squared is 0, times c is 0. So the only term that really sticks around is the b term. Here I have negative 3b, because negative 1 minus 2 is negative 3. That means if I divide 54 by negative 3, that I should get, let's see, what's 54 divided by negative 3? Is that 54, one time there, it's going to be negative, and then 3, negative 18. So it looks like our b is negative 18. And we've successfully used one of our x's. Let's look at the next x. Okay, I'm going to plug in x equals 2. So here I've got 54 equals a times 2 plus 1, and then 2 minus 2. Looks like the a term is going to disappear, plus b times 2 minus 2. Okay, looks like the b term disappears, and then 2 plus 1 squared. Alright, looks like we're solving for c in this next one. Like I said, the a term disappears because you have a 2 minus 2, which is 0, times a is 0. 2 minus 2 is 0, times b is 0. So it looks like we're just left with the c term here. 2 plus 1 is 3. 3 squared is 9. So it looks like I'm looking at 9c, which means that c is going to equal 54 divided by 9, which is 6. So we've solved for b and we've solved for c at this point. Still need to solve for a, and we need to figure out how to do so. So my third x, I'm going to let it equal 0. It's just the typical one I'm using there, because it can kind of be anything at this point, because there's not another x that I can input that'll cause b and c to cancel out, but not cause a to cancel out. So what I'm going to have to do is I'm going to have to use the value of my b, the value of my c, and I'm going to plug a x equals 0 in, and then solve for my a. So let's do that. So this is going to be, so remember we're setting x equal to 0. We're going to have 54 equals. We're going to have to flash back and forth. A times x plus 1. So a times 0 plus 1 times, let's see, that's 0 minus 2. Okay. Plus b. Now our b here we said was negative 18 times x minus 2. So 0 minus 2 plus c. C we said was 6. And that was x plus 1 squared, so 0 plus 1 all squared. Now we should be able to solve for our a. Just need to simplify here. 0 plus 1 is 0, or sorry, 0 plus 1 is 1. 0 minus 2 is minus 2. 1 times negative 2 is negative 2. So this first term simplifies down to negative 2a. If you need more steps and you need to do it a simple step at a time, go ahead and do it. But you've passed an algebra class to even be in this class, so a lot of times I'll combine very simple algebra steps. But you're more than welcome to take as many simple algebra steps as you need on your paper. Now I'm looking at negative 18 times negative 2. That's going to turn into positive 36. And then negative 0 plus 1 squared is 1 times 6 is 6. Okay, moving right along. 36 plus 6 is 42. So I'm looking at negative 2a plus 42. If I subtract 42 over, then I'm left with, let's see, it's going to be a 2 there. Left with 12 equals negative 2a, which means that a has to be negative 6. So we have our a, b's, and c's. Very nice, very nice. All right, so now we need to put it in our partial fraction decomposition form, right? So it needs to be a over x plus 1, so negative 6 over x plus 1, and then it needs to be b over x plus 1 squared, so negative 18 over x plus 1 squared. I'll put the addition between them for now. And then it needs to be c, which we know is 6 over x minus 2. Okay. And that is our partial fraction decomposition form. It is okay if you would rather write it as negative 6 over x plus 1 minus 18 over x plus 1 squared, and then plus 6 over x minus 2. The order really doesn't matter either, so if you kind of swap the order here, if you wanted to put the 6 over x minus 2 first and then do 2 subtraction, that's fine, as long as you get all the partial fractions right. But that is our final answer. Now, let's step forward into quadratic factors. So, form here is the linear expression for the numerator of the quadratic factor is the expression over a linear times a quadratic, so that we have a over linear plus b x plus c over quadratic, where a, b, and c are unknown constants. Our approach will be that once the decomposition form is determined, we'll multiply both sides of the equation by the common denominator on the left-hand side. We'll pick a value to eliminate some factors to determine unknown constants. Ideal values will be those that make the linear factor equal to 0. Second pick 0, then random last pick. All right, we want to decompose here. 8x plus 3 over x squared plus 4 times x minus 1. Now the difference that we have here in the denominator, what we have is we have this squared here and not necessarily on the outside of the form itself, if that makes sense. So we have the quadratic there in the denominator, right? So that's where the quadratic is coming from here in the definition. And then we also have this linear term, the x plus 1, right? That's where our linear term's at. Okay. So we need to set it up as a over the linear term plus bx plus c over the quadratic term. Simple enough. This is a over the linear term plus bx plus c over the quadratic term. Okay. And this is a simple quadratic. Quadratic is of the form ax squared plus bx plus c. Here, that middle term, the bx part, is not there. Okay, if you're talking about just solely the quadratic form of that denominator. Now, we need, so that's our form. We need to now multiply both sides by the denominator of that left-hand side. So essentially what we're doing here is we're doing 8x plus 3 times x squared plus 4 times x plus 1 all over x squared plus 4 times x plus 1 equals a times x squared plus 4 times x plus 1 all over x plus 1 plus bx plus c times x squared plus 4 times x plus 1 all over x squared plus 4. Oops. Alright, now, what that's going to allow for, as always, is a lot of cancellations. So that cancels, the x plus 1 cancels on the a, the x squared plus 4 cancels on the bx plus c. So that we get a semi-simplification here, where we have 8x plus 3 equals a times x squared plus 4 plus bx plus c times x plus 1. Okay. So, I'm going to rewrite what we just wrote here on the new slide. 8x plus 3 equals a times x squared plus 4 plus bx plus c times x plus 1. Now, we've got some things that are going to allow some zeros here. So, here, I could let, if I looked at it, it says pick value to eliminate some factors to determine unknown constants. Ideal factors, or ideal values, will be those that make linear factors equal to 0. Second pick 0, and then random last pick. Okay, here's the deal. Easiest one I can choose first is x equals negative 1, because I'm looking at this term here. That cancels out that bx plus c term, and we can automatically solve for a. So let's go ahead and push through that. So here I'm going with 8 times negative 1 plus 3 equals a times negative 1 squared plus 4 plus b times negative 1 plus c times x. Sorry, not x. Got to input that negative 1 in for it. negative 1 plus 1, which zeroes itself out. All right, so here we're looking at negative 8 plus 3 equals, let's see, negative 1 squared is positive 1, plus 4 is 5, so I'm looking at 5a. And then negative 1 plus 1 is 0, so it zeroes this whole entire term out there. Fair enough. So that we're really just looking at negative 8 plus 3 equals negative 5, which equals 5a, so that a has to equal negative 1. Okay, we've solved for our a. Fair enough. All right, now, if we look back at this term here, right? If I were to allow, looking at the second term that I have right here, if I were to allow my x to equal 0, right? Second pick 0. That's what it's suggesting there. If I allow my x term to be 0 there, my b cancels out, and then I can just solve for my c if I go ahead and just plug in my a value here of negative 1. So let's work on doing that. So I'm plugging in 0 for x, so it's going to be 8 times 0 plus 3 equals, I'm going to go ahead and plug negative 1 in for a, 0 in for x, so it's 0 squared plus 4 plus b times 0 plus c, and then 0 plus 1. Okay, 8 times 0 is 0, leaves me with a 3 here. 0 squared is 0, plus 4 is 4. 4 times negative 1 is negative 4. B times 0 just makes the b go away. 0 plus 1 is 1. So really I'm just looking at a plus c here. So that c must be 7. Right? If I add the 4 over to the 3, I get c equals 7. Now I have my a and my c. If I plug those values in, I can do a random last pick in order to be able to solve for my b here. My random last pick, I'm going to let x equal 1, because if I let x equal 1, it's just b times 1, which might be a pretty simple b to work with on that last step. So we're going to let x equal 1, and then we're going to, plug a and c in and then solve for b. Let's do that. So here I'm looking at 8 times 1 plus 3 equals a times 1 squared plus 4. Oh, remember we said we were going to substitute our a in. Oops. Let's go ahead and substitute our a in. Our a here is negative 1. So I'm going to do negative 1 right there for a. Got to remember to substitute them in. Now, plus b times 1. Now, plus c. Plus c, which is 7. And then here I'm going to get 1 plus 1. So plugging that x in. Now let's simplify. 8 times 1 is 8, plus 3 is 11. 1 squared is 1, plus 4 is 5, times negative 1 is negative 5. If you need to take more steps, by all means take more steps. Now here, b times 1, okay, is going to be, b times 1 is going to be b plus 7. Kind of got to leave that alone now. And then 1 plus 1 is 2. So this simplifies down to 11 equals negative 5. I'm going to distribute that 2. So plus 2b plus 14. Now negative 5 and 14 are going to give us an 11. So we get 11 equals 2b. And then negative 5 and, oh, I'm wrong. I got 11 equals 2b, negative 5 and 14, sorry, give me a 9. So I have 2b plus 9. If I subtract the 9 over to the left-hand side, I'm going to get that 2b equals, let's see, 9 minus 11 is 2. So that b has to equal 1. I have my a, b's, and c's. Beautiful. I have my a, b's, and c's. I'm going to change color so we can see our partial fraction written out nicely. Okay, my a is negative 1. So I'm going to put negative 1, over negative 1 over x plus 1. Okay, and then plus bx plus c my bx, so it'll be 1x plus 7 all over x squared plus 4. So that is my partial fraction decomposition. Right there. As you notice, the further along we get, the more complicated it gets. But mostly it's simple algebra steps that you have to keep up with. Simple processes with simple algebra steps you got to keep up with. They're just long processes. Let's try another one. Here it says we need to decompose this one into partial fractions. Here I have 7x squared plus 8 equals x squared plus x plus 3 times x minus 2, all in the denominator. Okay. Now, I'm going to set this one up. Linear term first. A over x minus 2 plus bx plus c in your numerator all over your quadratic, which is x squared plus x plus 3. Okay. All right, let's do this. Now, next step. Change color here. Next step, I need to multiply both sides by the denominator on the left-hand side. The x squared plus x plus 3 and the x minus 2. Remember, you're multiplying everything times that. This piece, and this piece. All right, so it's going to look like a times, I'm rushing. Don't need to rush. Jumping ahead of yourself here. I'm going to write all the steps out. Once you get really good at this, you can skip a lot of steps and kind of move on kind of quickly. So write as many steps as you feel like you need. If you don't feel like you need as many steps as this and you can do the cancellations pretty quick, fast, and in a hurry, go ahead and do the cancellations. But for those that might have a hard time following along, I'm going to try to force myself to write all these steps in so that you can see where you're going wrong if you're struggling. Almost got it. All right, we have distributed it to all three parts. Now it's going to allow us to do the cancellation. This piece cancels with this entire piece. The x minus 2 cancels on the a term, and the x squared plus x plus 3 cancels on that bx plus c term. Okay? All right. Let's continue. This simplifies down to 7x squared plus 8 equals a times x squared plus x plus 3 plus bx plus c times x minus 2. Now, let me ask you this. What appears to be the simplest one to turn in to cancel out some terms so that I can solve for my a? All right, I'm going to start out with x equals 2. Because if we plug x equals 2 in, 2 minus 2 is 0. It cancels out that whole bx plus c term, right? Now remember, the next one we're going to plug in is 0, so that we can cancel out the b term. And then we're going to plug in any random x to solve for the c term after we plug the a and b terms in. That is our process here. Let's go for it. Plugging in x equals 2 to start. 7 times 2 squared plus 8 equals a times 2 squared plus 2 plus 3 plus b times 2 plus c. My mind and my hand were doing two separate things there. And then we get 2 minus 2. All right. 2 squared is 4. 4 times 7 is 28. So I've got 28 plus 8 equals a. 2 squared is 4. Plus 2 is 6. Plus 3 is 9. So it looks like I'm going to wind up with 9a there. 2 minus 2 is 0. 0 times anything is 0, so that whole last term just kind of cancels itself out. Now here I have 28 plus 8. That's going to give us 36 equals 9a. So a has to equal what? A has to equal 4. Simple enough. All right. Now let's keep a as 4 and then plug x equals 0 in. Sure. So that's going to give us 7 times 0 squared plus 8 equals 4 times 0 squared plus 0 plus 3 plus b times 0 plus c times 0 minus 2. All right. 7 times 0 squared is 0, which leaves you with just the 8 on the left-hand side. 0 squared plus 0 plus 3 gives you 3. 3 times 4 is 12. B times 0 is 0. 0 minus 2 is minus 2. So here I'm just left with a minus 2c. All right. If I subtract the 12 over to the left-hand side, that's going to give me a negative 4 equals negative 2c. And then if I divide by negative 2, that's going to tell me that c just equals 2. So I have successfully solved for my a and my c. Just need to go back and solve for b. All right, so I'm going to input my a value, I'm going to input my c value, and then I'm going to choose any random x. The x I'm going to choose is 1. Once again, just to make the b term simple. So I'm going on to the next slide so that I can do that. All right, so I'm going to rewrite it so we know where we're plugging it. 7x squared plus 8 equals a times x squared plus x. I think it's plus 3. Yep. Plus bx plus c times x minus 2. Okay. Remember that we've already solved for a and we've solved for c. A was 4 and c was 2. And we're plugging in x equals 1 now. All right, let's do it. 7. You don't have to rewrite all that on your paper. I'm just rewriting it so we can all see it on this slide. Ideally, on your paper, you would just continue writing down and solving down. But I want us to be able to see everything we're doing. So that's why I took the time to rewrite it. All right, I've got 7 times 1 squared plus 8 equals, I got to plug the 4 in for a. X, once again, is 1, so it looks like 1 squared plus 1 plus 3 plus b times 1 plus c here. Oh, c was 2. That's just a really terrible looking 2 that I wrote right there. All right, plus 2. And then x is 1, so I'm going to plug 1 in there. Now we just have to simplify. So 1 squared is 1 times 7 is 7. 7 plus 8 is 15. So the left-hand side simplifies down to 15. 1 squared is 1, plus 1 is 2. 2 plus 3 is 5. 5 times 4 is 20. I'm doing a lot of little small algebra steps all together instead of rewriting this whole phrase. That would have been 5 or 6 different times. So that first term here simplifies down to a 20. B times 1 is b. So here I've got b plus 2. 1 minus 2 is negative 1. I'm going to distribute that negative 1 to both of those terms. So I'm looking at 15 equals 20 minus b minus 2. Fair enough there. 20 minus 2 is 18. So it looks like 15 equals 18 minus b. You can subtract 18 over to the left-hand side, and you're going to get negative 3 equals negative b, so that b has to equal 3. Fair enough. All right, now I just have to put my a, b's, and c's in my partial fraction form. Partial fraction decomposition form. That form is a over x minus 2. So 4 over x minus 2 plus bx plus c. So plus bx 3x plus c, which is 2, all over x squared plus x plus 3. And we are good to go. That is our partial fraction decomposition. All right, I think this is our last one. Yep. Example 10 will be our last one. Let's try it. Here I have negative 14x squared plus 9x minus 3 all over 3x squared plus 2 times 5 minus x. Sure. Okay, our partial fraction decomposition here is going to look like a over 5 minus x plus bx plus c all over 3x squared plus 2. Okay, remember we'll then need to multiply both sides by the common denominator on the left-hand side. Okay, so we're distributing that to this term, to the a, and to the bx plus c term. I'm going to write it all out. Here we go. So 3x squared plus 2 times 5 minus x times negative 14x squared. So really kind of rough looking one there. Plus 9x minus 3 all over 3x squared plus 2 times 5 minus x. So you can see the cancellation that's going to occur there. Then we're going to have a times 3x squared plus 2 times 5 minus x all over 5 minus x. You can see the cancellation that might occur there. And then we're going to have bx plus c times 3x squared plus 2 times 5 minus x all over 3x squared plus 2. You can see the cancellation that will occur there. First term, the entire denominator cancels out. Second term, the 5 minus x cancels out. Third term, the 3x squared plus 2 cancels out. Easy enough. So we get negative 14x squared plus 9x minus 3 equals a times 3x squared plus 2 plus bx plus c times 5 minus x. Now, the x terms we're going to want to use here. We want the 5 minus x to zero out. So I'm going to let x be 5. Remember, the second one that we're going to use is x equals 0. And then we're going to use a random last term. Probably going to just let x be 1 again. So that's kind of going to be how my layout's going to work here to solve for these different variables. Let's start with x equals 5. Okay, negative 14 times 5 squared plus 9 times 5 minus 3 equals a times 3 times 5 squared plus 2 plus b times 5 plus c times 5 minus 5. So that second term there is going to cancel out because 5 minus 5 is 0. All right, let's see if we can simplify this first term. Keep in mind, you can use a calculator in this class by all means. So I don't expect you to have to multiply 14 times 5 in your head, but if you did, it would be 70. So we're looking at, no, it wouldn't be 70. 5 squared is 25. So you're looking at 14 times 25. It would be negative 350. 9 times 5 is 45. And then here we have the minus 3. Okay. 5 squared is 25 times 3 is 75 plus 2. That last term cancels out because 5 minus 5 is 0. 0 times that entire term cancels that entire term out. All right, let's simplify this left-hand side. We're looking at negative 350. Let's see. Negative 350 plus 45 minus 3 should simplify down to negative 308. And then 75 plus 2 is 77, so we're looking at 77a. If I divide 308 by 77, I get that a should be negative 4. By all means, use your calculator for those simplifications. All right, now that we have a, we can plug a in, and we can also plug this second x in. That's x of 0. Okay, so let's go for it. I'm going to change colors so I can write it on this line here. It's going to be negative 14 times 0 squared plus 9 times 0. Oh, this one's going to be really nice. We've got a lot of cancellations happening. Now I'm going to go ahead and plug in my a, which is negative 4 times 3 times 0 squared plus 2 plus b times 0 plus c times 5 minus 0. Awesome. 14, negative 14 times 0 squared is 0. 9 times 0 is 0. Minus 3. So left-hand side simplifies down to a minus 3. 0 squared is 0. Times 3 is 0. Which just leaves you with a 2 in that parentheses. 2 times negative 4 is negative 8. Okay. B times 0 is 0. It just leaves you with the c there. 5 minus 0 is 5. So it really just leaves you with a 5c. Okay. If I add the 8 over to the left-hand side, make sure I'm doing this right. If I add the 8 over to the left-hand side, I'm going to wind up getting 5. So 5 equals 5c, which means that c equals 1. Super nice, super nice. I added the 8 over to the left-hand side. All right, that's how I got the 5. Divided 5 by 5 is 1, so c equals 1. I have my a and my c. Whew, on to the next slide. I have my a and my c. My a is negative 4. My c is 1. And I think I'm going to let my x be 1 as well in this next write-up. Oops. So let's do that. Let's do negative 14. Is it negative 14? Yeah, it's negative 14 times 1 squared plus 9 times 1 minus 3 equals a, which we said is negative 4, times 3x squared plus 2. So 3 times 1 squared plus 2. All right. Plus bx. Don't know what b is, but our x here is going to be a 1. Plus c. Plus 1 because c is 1. Times 5 minus x. So 5 minus x, which in this case is 1. All right, let's simplify. 1 squared is 1. Times negative 14 is negative 14. 9 times 1 is 9. Minus 3 is 6. Okay. Now, we've got 1 squared is 1. 1 times 3 is 3. 3 plus 2 is 5. 5 times negative 4 is negative 20. Okay, I have this first term simplified. Next term here is going to be b plus 1, because b times 1 is 1, plus 1 is b plus 1. And then 5 minus 1 is 4. Sure. I'm going to distribute that 4 to that term. Now, negative 14 plus 6 is going to give us a negative 8. I'm going to distribute 4 to the b and to the 1, so it looks like plus 4b plus 4. Negative 20 plus 4 is negative 16, so I'm looking at negative 8 equals negative 16 plus 4b. Okay, if I add 16 over to the left-hand side, I'm going to get 8 equals 4b. If I divide by 4, I get that b equals 2. I have my a, I have my b, I have my c. There it is. Okay, now I just need to plug it back into our partial fraction. So a, which is negative 4, over 5 minus x plus bx plus c, so 2x plus 1, all over 3x squared plus 2. So all I did was take the partial fraction area here, plug in the a, b, and c, and we have our final answer right there for the partial fraction decomposition of our initial equation. And that completes part 2 of partial fractions. If you have any questions, don't hesitate to reach out by email. Try your homework. You should be able to complete your homework on partial fractions now. If you have any questions on it, don't hesitate to reach out. Other than that, I will see y'all next time.